What if your brain is already adapting to a reality that isn't real? Every hour spent in a virtual world isn't just entertainment. It's a neurological workout. We're about to uncover how these digital landscapes are subtly, yet profoundly, reshaping your perception of what's true and what's simulated. Remember when virtual reality felt like science fiction? Today, it's daily life. From immersive gaming and social metaverses to virtual classrooms and AI-powered simulations, our brains are spending more time in digital spaces than ever before. And whether we realize it or not, those experiences are changing how we think, feel, and remember. When you enter a virtual world, your brain doesn't treat it as fake. The same neural circuits that process motion, emotion, and presence in the real world light up in VR. Areas like the hippocampus, responsible for spatial memory, and the visual cortex, responsible for interpreting reality, can't easily distinguish between what's happening in the headset and what's happening around you. To your brain, immersion is reality. This is why virtual exposure therapy can help veterans overcome trauma, or why training in VR can improve real-world performance for surgeons, pilots, and soldiers. The simulations activate genuine neural learning. But there's a flip side. The more realistic these digital environments become, the more your brain rewires itself to treat them as normal. Over time, your sensory calibration shifts. Studies from Stanford's Virtual Human Interaction Lab show that extended VR use alters how the brain maps body ownership and spatial awareness. After just 30 minutes in a headset, participants often misjudge distances and experience temporary changes in proprioception, the sense of where your body is in space. In longer-term users, researchers have observed reduced sensitivity to real-world stimuli and delayed adaptation when switching back to the physical environment. In other words, the more time we spend in virtual reality, the more our brains start to blend realities. Neural pathways governing attention, empathy, and even moral judgment adjust to the virtual context. Inside a headset, consequences are limited, feedback loops are instant, and the environment always responds. Outside of it, reality moves slower, feels heavier, and doesn't bend to your will. Psychologists call this phenomenon environmental conditioning. It's the same mechanism that allows your brain to adapt to new lighting conditions or new languages. Except now, it's adapting to digital laws of physics and virtual social norms. And because the brain is plastic, it learns fast. Imagine a future where virtual memories feel as vivid as real ones. When you recall a moment in a simulation, the same neural traces light up as if it truly happened. Scientists have already demonstrated this with spatial memory experiments. VR-generated experiences can encode memories almost indistinguishable from real ones. The boundary between imagination and experience is fading. As virtual worlds grow more immersive, with haptic feedback, brain-computer interfaces, and AI-driven realism, the brain's ability to tell the difference will only weaken. This isn't a hypothetical, it's a neurological inevitability. We're teaching our brains that digital environments deserve the same neural respect as physical ones. That raises a profound question. Is your brain prepared for the metaverse? If the virtual becomes just as neurologically real as the physical, what happens to identity, to empathy, to truth itself? Already, we're seeing early signs of reality confusion, the blending of digital and lived experiences in memory recall. For some, virtual avatars begin to influence real-world self-image and confidence. For others, constant immersion leads to detachment and derealization. The challenge ahead is not escaping virtual worlds, it's mastering how we integrate them. Because this isn't just about technology, it's about neuroplasticity. Every simulated experience leaves a trace. Every virtual emotion shapes a real neural pathway. Our brains evolved to adapt, and they are adapting again, this time to realities we built ourselves. The question is whether we can stay in control of that adaptation, or whether the next generation will grow up neurologically wired for worlds that never existed. Reality is no longer fixed, it's programmable. And your mind is learning the code. If you found this exploration valuable, subscribe to Future Forged where we decode how emerging technology is transforming not just our world, but the human mind itself.